In this example, we're going to sketch a graph of y equals sine of 1/2 x to compute the length of one cycle or the period. Setting up 0 less than or equal to the argument, which is 1/2 times x, less than or equal to 2 pi, which is the typical period of the basic graph of the sine function. And next, we're going to solve for x. This time, we're going to multiply all by 2 to get the interval x between 0 and 4 pi. The period is the right end of the interval minus the left end of the interval, or we say the 4 pi is the period of the graph y equals sine of x over 2. After we get the period, we're going to divide by 4. So this one is from period divided by 4, or 4 pi divided by 4, and come out to be the increment pi. Start with make a list of the 5 key points. Use the first or the left end of the cycle. So going to be 0. And then the next with the increment pi. Next going to be 2 pi, 3 pi to finish the cycle. Stop at the end of the period, which is 4 pi. So we get 5 key points. For the 5 key points, it's convenient when you make a list on the table. On the table, we start from the 0. So 0, and the next is the pi, and then 2 pi, 3 pi, 4 pi. The function is y equals sine of 1/2 x. The 5 key points, as you recall, the value of the sine is from 0 and then 1, 0, -1, and 0. I put it up here so we'll try not to confuse you guys. So 0 on the unit circle, this is for an angle 0, and then 1 for an angle pi over 2, and back to 0 at an angle pi, -1 at 3 pi over 2, and then back to 0 at an angle 2 pi. So I use this as a 5 key point value. To complete the table, we're gonna just replace it with a 0, 1, 0, -1, 0. Put together in the order pair form, 0, 0, pi, 1, 2 pi, 0, 3 pi, -1, and the last is 4 pi, 0. So we're gonna put them together on the xy plane. Use the increment like from 0 here, and this is pi, this is 2 pi, 3 pi, and the last is 4 pi. The maximum value is 1, minimum is -1. So I'm gonna put a note here. This is the max, and this is the minimum. I use the increment here, 1, -1. Locate the order pairs on the xy plane. First one is 0, 0. Next is pi, 1. Next is 2 pi, 0. 3 pi, -1. And 4 pi, 0. Connect all the points with the smooth curve. And now we get one cycle of the graph of the y equals sine of x over 2. With the amplitude, the A is 1 for these problems. Therefore, the amplitude equals absolute value to A or 1. And the range gonna be the interval from the minimum to the maximum. The period we compute by setting up the inequality, and we obtain the period of 4 pi. To summarize, the amplitude and period for the sine and cosine function. In the pattern of the function y equals a times sine of bx, or a times cosine of the bx, the value a, or the coefficient, we use to find the amplitude. So the amplitude is the absolute value of the a. If a is less than 0, we have the reflection about the x-axis. The period, the typical period is 2 pi, but if the argument b is not 1, so you're going to divide the 2 pi by b to obtain the period of that function y equals a sine bx or a cosine of bx. The range is going to be the -a, comma a. For the case of the a is positive positive number. Otherwise, you're going to put the absolute value to protect it from switching the sign. Another case, for the b less than 0, we're going to use the property of the odd-even functions. If you recall, the odd function, the function at negative x is the same as negative f of x. For the even function, the function at negative x is exactly the same as the original function. The even function is the function cosine of the x, the secant of the x. For the odd, it's going to be the sine of the x and the reciprocal, which is the cosecant of the x, and also the tangent function and the reciprocal of the cotangent function of the tangent function.